Hello friends, welcome back to my channel KarthikSiva World. Today I am going to explain you about indexes in SQL Oracle. Okay, first, what is meant by indexes? Indexes are used to quickly locate data without having to search every row in database table. Okay, every time table is accessed. Okay. Let's take an example. Suppose we have one book to read, and every time when we open the book, the first page will be index page. Okay, like this. Preface 3, number third page, induction fifth page, chapter 6, 101 page. Like this, if we have index page, okay, we will go, if we want to go to chapter 7 page, then directly we'll go to 113 page instead of searching whole book. Whole book searching will be taking time. Where is chapter 7, like that? If we have index page, we can directly go to the 113 page. Okay, like that in Oracle also. For tables, we'll create the indexes. If the table has millions of data, then if you are querying for only one product or some of the products, then it will be searching the millions of the data one by one. Then it will be time consuming. So to increase the performance of the queries, we will be going for the indexes in SQL. Okay. So these are some of the terms: row ID, row number and cardinality, which I want to explain before going to types of indexes. Okay. The first one, row ID. What is meant by row ID? Row ID is nothing but the physical address allocated to the particular row whenever we are inserting the data into the table. Okay. I have one table, so I will be showing that. Okay, select star from the data. I have created one table, for example, and I have inserted 20,000 records into that. Okay, this is the table which I have created. Okay, and we'll see what is the row ID allocated to these rows. Row ID, comma, I will give the ID also. Okay. See, this is the physical address or physical memory allocated to the particular row ID. Okay, for every row. Okay, this is the ID in the table. This is the physical address allocated to the row IDs. Okay, and it is permanent. Okay, and what is meant by row number? This is not permanent. This will be dynamic. Whenever we are querying, that time it will create the numbers based on the rows which we are querying. Okay, suppose user data, row number, okay, comma ID. See, if I give for all the records, it is giving 1, 2, 3, 4 like that. For 9/28th record, it came 1. So consecutively, it will give the numbers. Okay. See, for everything it is giving the numbers. Okay. So what is the difference between row ID and row num? Row ID is permanent, and if I query for particular row ID, it will give me the result. But if I query the particular row number, it will not give, because it's not permanent. It will be generating dynamically based on the particular rows we are allocating. Okay, these 1 2 3, it's not permanent. Okay, if I query for from 923 930 931 only 3 records, then it will give 1 2 3 for these 3 records. Okay, let me show you that. Select star row number comma id from user data, where id in, let's pin this one so that we can see the difference. 929 930 931. Okay, you observed here for 929 it gave 1. Okay, here for 928 it gave 1. So it will be generating dynamically based on the number of rows we are querying. Okay, we can query in the where class also row number. User data, if we want some rows in table, you can give row num less than 5. Okay, it will give the first 4 records. Okay, if I give equal to 5, will it come? No, data will not come, because row number will be generating dynamically and number 5 will not be allocated to any record. Okay, based on particular rows will come from 1. Then the next topic is cardinality. Okay, now you know the difference between row, what is row ID and what is row num. Row ID is permanent, row num is temporary. Okay, row ID is physical address, and row num is generated dynamically when we are querying the particular data. Okay, what is meant by cardinality? Cardinality is next number of distinct values for particular column. Okay, I can show you. See, for gender column, we have only male or female. Okay, what is the cardinality of this column? 2. Number of distinct values are 2. Okay, how to know that? Select distinct gender from user data. You know the distinct keyword, right? It will give the distinct records. M and F. Okay, if you want to know the count, the cardinality of the gender column, what's the cardinality? It is 2. 2 distinct values are there. Okay, so what is cardinality? It is nothing but number of distinct values for the particular column. Okay, but for ID, if you see in the user data, it is unique. ID 928, 929, like that. So, what is the cardinality for ID? It should be number of rows in the table. Okay, we can see distinctive star comma count of star. Distinct ID. Okay. See, it's coming the same. So what is the cardinality of the ID column? It is 20,000. Next, what are the types of indexes? There are 5 types of indexes in the Oracle: bitmap indexes, bitree indexes, and composite indexes, and function based and unique indexes. Okay, let's talk about one by one. First is bitmap indexes. Okay, bitmap indexes. What is meant by bitmap indexes? It will allocate the bits for each and every row ID based on row ID. Based on row ID, it will allocate the bits. Okay, and bitmap indexes we can use for low cardinality columns. Okay, it will create the bits for each and every row for column values. Okay, let's take the example. I will explain you in example so that you can understand more better. So just use date. Okay. So gender column has gender, age. Okay, like that. A few values will be there, right? And we will be querying frequently. Okay, if we want to know uh, how many records are there with the gender male, how many records are there with gender F, if age column is there, what is how many records are there with the age 60. Okay, like that. If you are querying more frequently this low cardinality columns, then for faster access we can use bitmap indexes. Okay, for only low cardinality columns. Okay, for high cardinality columns it will be a waste. Okay, I will show you the example. So whenever table data is inserted, row ID will be generated. Correct? Just now we discussed row ID 2, row ID 3. Okay. Here gender M and F. First row. If it is M, then it will be 1. Okay. If it is for second row, it is F. So it will be allocated 0. And for row ID 3, it is M. Then again it is 1. Like that. Okay. For F, for first row it is 0. For second row it is female. And for third row it is male. So like this it will generate the bits and store it in memory. So whenever we are querying for number of male candidates or female candidates, directly it will check these bits and give the result instead of scanning the whole table, so that it will be more performance. Okay, performance will be more. So let's Let's create the index and let's see with the example. Okay, the performance difference. Okay, what is the syntax for creating index is create create it is bitmap index, so we need to give particularly bitmap keyword, create bitmap index. Okay, index name I am giving it as uh, bit underscore index. Okay, on table name, what is the table name? User data. And column name is gender. Okay, this is the syntax. We just need to give create bitmap index and the index name on table name with the column name. Okay, let's execute this one. See, the index bit index created. So we'll check in the table for checking the all the indexes in system tables. The system table for checking the indexes is all underscore indexes, where table name equal to user underscore data. Here it will be in these columns all the values will be in uppercase. Whenever you are querying the system tables, give it in uppercase. Okay, see, index name is bit index and the owner is prod user. Okay, index type is bitmap. See, this is the index type. It is showing bitmap index, table owner is prod, your table name, table type is table. Okay, non-unique, it's not unique, it has distinct duplicate values, male female like that, so it is showing non-unique. Okay, now I have other table. Start from user data 1. Okay, on this table I have not created any index. Okay, so we'll query both the tables and we'll see the performance difference. I have 20,000 columns in this both the tables. Okay, where gender equal to F. Okay, same thing here also I will give here gender equal to same thing I will give. Okay, now let's query this one and how to know the explain plan, so that you can know the execution plan. Okay, for the SQL, see, it is showing cost as 20 for user data table and it is showing, see, bitmap index it is using. Here it is showing bitmap index. Let me pin this and query for this also. Here cost is 20, right click, explain plan. Here it is showing 27. Here it is showing little difference because I have only 20,000 data. In real time world you have millions of data, so that there will be much more difference. Okay, here it is using full table scan, full, and in this one it is using bitmap index, so the cost is 20. Okay, now you know the difference between without bitmap index and with bitmap index. When we have to use this bitmap indexes, when the column has low cardinality. Okay, and if you are using frequently that column. Okay, and if the table is updating, more more updations are there in the table, then whenever updation, deletion or insertion is happening, these indexes will be, should indexes also should be updated. So based on number of DML operations doing on the particular column, you need to decide whether we need to create index, whether it is useful or not useful. If it is more frequently updated, more headache will be there for the SQL engine to update the indexes. Okay, based on that, if it is useful you can create, if it is not, then you need to think about the alternative solution. Okay, then next we'll see the B tree indexes. B tree indexes, it will store the data in the tree form. It is the default index in the SQL. Okay, let's take one example. See, like this it will store in the internal memory for the B tree indexes. Like there will be one parent node and number of branches and the leaf nodes. Okay, so whenever if you are querying for 145 record, it will be navigating from the parent node to leaf node. Okay, when you are inserting, okay, it will insert for 100 less than 100 this side branch. Okay, and 155, okay, this side branch. Okay, less than 155 and greater than 100 this branch, and greater than 155 and less than 226 this branch. Okay, like this it will store the data in the tree form. Okay, this is the default index which we will use in the Oracle. And the syntax for this creating the index is create index. You no need to give the B tree keyword. Create index, index name I am giving it as B tree index on table name, and the column I am creating for ID column. Okay, the syntax is simple. Create index, index name on table name of column. Okay, only for bitmap indexes we need to use the bitmap keyword. Okay, this is the B tree indexes is the default index in the Oracle. Okay, see, I have created, index is created. Okay, now let's query this user data. Okay, all indexes. Let's see how it is showing. Earlier it is showing only bitmap index, right? Now it should show B tree index. See, it is showing index name as B tree index. Okay, index type is normal because it is default index. Okay, and it is also non-unique. It is showing because we have not created any unique index or primary key on that. Okay, when I am explaining unique index, you can show the difference in this column uniqueness. Okay, so I have created. Now we'll see the difference in performance. Okay, how the cost difference is coming. Okay, ID I'm giving yes, some ID will give. Okay, 938 equal to its number, so no need to give colons, right? 938 ID I'm using same column because same value, because we can see the cost difference. How to show the cost? Explain, plan. Or if you press F10 also it will give. Okay, what is the cost? 27, and it is showing full table scan. Okay, and if you see this one, which has bit tree indexes, it is showing. Now see, you can see the most cost difference. Earlier it came 27. Okay, here it is showing b tree index it is using, and the cost is only 2 2 and 1 5. Here it is 27. So whenever you are reading any topic, uh, practice, then you will be knowing the more differences and more questions will come, more you will learn. Okay, can we rename the index? Yes, we can rename the index. Okay, the syntax is alter index and renaming it as b3 index 1. Okay, rename to b3 index 1. Okay, see, index b3 index altered. So same thing you can check here also. This is the refresh button. If you refresh, it will refresh the columns. Okay, with the current values. b3 index 1. Okay, like this you can rename the index. If you want to drop the index, I don't want this index and I want to drop the index. Okay, drop index and index name, and this index name is unique. You can't give for different tables same index name. Okay, that index b3 index 1 is dropped. Okay, what is the syntax? Drop index and index name. Okay, now we can see here the b3 index from the all indexes table is vanished. Only bitmap index is available. Okay, now we saw how b tree structure will be there in internal memory, like this: parent and leaf node with branches. Okay, whenever we are querying, it will navigate to the leaf node or particular column. Okay, and how to create the index? It is the default index. Okay, which will be mostly used in Oracle. Okay, and the cost difference we saw, and performance difference. Okay, you can practice for more columns so that you can understand more. Okay, now is b3 indexes and bitmap indexes, how to rename index and how to drop the index. Okay, for creating, create index; for for renaming, alter index; for dropping, drop index. Okay, what is meant by composite indexes? Okay, composite means we can use one or more columns for creating the index. Okay, here I am using only id. If I am querying mostly in queries, okay, where clause with two columns, okay, then I need to use the composite index. Okay, here I should use based on the where clause what we are using more. Okay, if you are using two columns more, then you can use two columns. If you are using three columns for querying, okay, you can use three columns. Okay, So if you are using more than one column, it is called composite indexes, and it's the functionality, everything will be same as P-tree indexes. The only difference is we are using more columns like ID and the columns in user data. ID and first name if you are using more, okay, then I should use composite, I should go for composite indexes. Okay, I will show you that one also. I am giving it as first name, ID comma first name. It is composite index example. Create index, composite index. You can give any name for the index. Okay, for understanding I'm giving composite underscore index. You can give any index name you want, but give it as understandable. Okay, if you are creating on ID on particular table, you can it as give it as user data underscore ID index. Okay, like that, if you are querying the system table, you will be understanding more. Okay, or all indexes if you are querying, and if you are not giving table name also, you will be able to understand. It's better to give table name and a column name and the index. Okay, like that. Let's create this composite index is created. Now let's see in all indexes. Now we have dropped the beat tree index. So now only beat map index and composite index. See, it is showing composite index, and it is normal, prod, owner, table name is user data, and table type is table, uniqueness is non-unique because it's not unique index. Okay, now let's in where clause I am giving the first name also, where and first name equal to I'm giving it as John. Only two values I have inserted, one is John and one is Jenny. In the script I can show you, one is John and one is Jenny. Okay, I'm querying it is for John. Okay, we need to give the exact name, right? It is case sensitive. J I'm giving it as capital. Let's see the first name FIRST. Okay, I gave the column name wrong, that's why it is giving me as first name invalid. Okay, the cost it is giving as 27, and full table scan for user underscore data underscore one table because it has no index on ID and first name. Okay, let's give here. See the difference. In composite indexes, the column which will be using more, okay, should be giving the order. The column order also will make the difference. Okay, if ID column if you are using first, then you should give the ID column first in the index creation. Okay, here cost it is giving as 1. See, it is 1, it is giving in 1 second, and here it is giving as full table scan and 27 seconds it is giving. Okay, if you have millions of records, you will be knowing the more difference, and it when it is taking time for querying one column without index, then it will make the difference. Here I have only 20,000 records I have inserted, so it is showing the less difference. Okay, next, composite indexes, I hope you understood. Next, function based indexes. Okay, when you are using functions in where clause, like first name, I don't know how it is stored in table. Okay, and if I am querying it as upper function, I have explained, right? It will make the columns in uppercase, and then it will compare with the given string John. Okay, if I am using like this, upper of first name equal to John. Let's see the data here. Okay, here it has 928. Okay, John 928 it has. So it's giving, see, first name is in uh, first letter is in uppercase, remaining letters on lowercase. So I am using it as upper of first name. So whenever you are using some functions, upper, lower, or some other built-in functions, oracle functions in where clause, then you should go for function based indexes. Okay, function based indexes. So how to create the index? Create index. Okay, I am giving it as function index. It's not a keyword, it's the name. Anything I can give. This time I will give it user data. Okay, underscore function based index. Okay, of create index name I am giving as this one, user data f index on the table name is user data. Okay, I am dropping the composite index so that you can understand more. Drop index, what is the composite index name? Let's for knowing the index names, what we need to do, we should go for composite index. Okay, query the system table so that you can know the index names, what all indexes are there on that table. Okay, I'm dropping this index composite index as of now so that I will create function based index. Okay, it's dropped. Now I am creating the function based index. User data. Okay, what I should give? Upper of first name. Okay, so that index will be created on, see, user data f index created function based index. Okay, what is the syntax? Create index name on table name and the function name. Okay, I am using upper. If you are using some other function, you can use that. Okay, upper of first name. Okay, we'll see in the all indexes also, this is the refresh button. If you refresh, it will be refreshing with current columns. User data f index function based normal. Okay, index type, it is showing by SQL, it's not given by me. only index name I have given, so it is given user data f index. It is function based normal. Okay, now we'll see the cost difference. Upper of first name equal to John 928. Okay, see it is giving it as 27 for user data underscore 1, which has no index, and it is giving it as full table scan. It's a full, it is showing. Right click, explain plan. See here it is showing user data f index, and it is showing by index row id, batched, and range scan. It is showing the cost difference. See here it is showing as 5. Okay, here it is showing as 27. So what is function based index? When you are using mostly the functions in the where clause, okay, whenever you are using function, and if you are using only one time, then it is of no use to create the indexes. Okay, if you are using most frequently that function, then you should use the function based index. Okay, it is unnecessarily we should not create the index, because whenever using DML operations, then all the indexes on the table should be updated. So it will take more time for the SQL. It will be more burden for us. Okay. If the table is read only, then you can create the more indexes. Okay. So I have explained you about bitmap indexes, bit-tree indexes, and composite indexes for one or more columns, and function-based indexes. Okay, and the unique index is nothing but it will not allow distinct values to insert into this table. Okay, user data, unique index on user data for of I'm giving id column. Okay, first I am dropping that function based index user data f index. See, I have created only one table and I have practiced all the indexes. Okay, like this you can also practice. I have dropped the function based index, and for unique index and bitmap index we should give the keywords. Okay, create bitmap index, and here create unique index, index name on user data first name. Okay, sorry, I'm giving for id first name is, I'm not giving. See, create user data u index created. Okay, see here the previous records are there when I queried previously. If I refresh this, it will be updating with the unique index. Now you can see the difference in this uniqueness column. Unique it is giving. Okay, like this you can, and you can check the cost difference as homework. And if you have any queries on indexes, then you can comment. Okay, so that I will reply in the next video, or in the same comment also I will reply. Okay, thank you so much. I hope you understood the indexes in detail, and you will practice more at home. Thank you everyone. If you like this video, please subscribe, share to your friends so that it will reach to more people. Thank you everyone. Bye bye.